Problem 19. Government workers. The Bureau of the Labor Statistics reported that 16% of U.S. non-farm workers are government employees. In this sentence, is telling us that for the whole country, 16% of the non-farm workers are the government employees. We are taking a sample of 50 workers. In part A, is that approximate to use the normal approximation to find the probability that less than 20% of individuals in the sample are government employees. If so, find the probability, and if not, then explain why not. So we know that if we want to find the probability, then we have to apply the center limit theorem for the proportion problem. This problem is for the proportion because it's given us the proportion, the percent. So we have two conditions to apply the center limit theorem. The first one is NP have to be greater than 10, and n times 1 minus p is greater than or equal to 10. Now let's plug in the number. So we have n is 50 and p is 0.16. So 51 minus 0.16, we expect the result greater than 10. So the first one, we have 50 multiplied 0.16 is 8. This is not greater than 10. So we cannot apply the center limit theorem. So we cannot find the probability that less than 20% of the individual. Okay. So for part B, a sample is 90 workers. So N is 90. The probability is not changed is 16%, which is 0.16. Now let's double check NP and N1 minus P. So 90 times 0.16 and 91 minus 0.16. 90 multiplied 0.16 is 14.4, and 1 minus 0.16 multiplied 90 is 75.6. Both of them are greater than 10. Then we can apply the center limit theorem. The center limit theorem says the mean of the sample is the same as the population proportion. The sigma is square root of p1 minus p divided by n. So p is 0.16. Now we plug 0.16 in. Okay, after that I will input them in the GeoGebra. So mu is p, which is 0.16, and then sigma is the square root, and then I do the divide. On the top we do p minus 0.16 multiply parenthesis 1 minus 0.16 in the bottom. In the bottom we are putting 90. Okay, so we input finish, then we read the problem. The problem in part A say, in part B is say that find the probability more than 20%. So you draw, I need to erase part A so we have more space. Okay, so in part B we draw the graph now. So the mean is the same as the P, which is 0.16 in the middle. We have 20%, which is 0.20, and we draw the line. And then we want to find more than, so it's shade on the right side. Okay. Now we shade on the right side, and we want 0.20. Now we read the probability is 0.1503. Part C, find the probability that the proportion of workers in the sample of 90 who are government employees is between 0.15 and 0.18. So for part C, 0.16 in the middle, 0.15 is on the left, 0.18 is on the right. We want the area in the between. Okay, so I will click on the between, and then I put in 0.15 and 0.18. And we read the answer is 0.2997. In problem D, find the probability that less than 25%. So less than 25%, so we shade on the left hand side. So we click on the left, and then we put in 25. And we got the answer is 0.9901. Problem E, would it be unusual if the proportion of government employees in the sample of 90 was greater than 0.25? So we want to know what is the probability that greater than 0.25 first. So if you want to draw the picture, then this is the picture that you should draw for part E. 0.16 in the middle, 0.25, and then we shade on the right side. And we want to find the area for that, right? Now we go to the GeoGebra, and we change it to greater than, and then we input 0.25. Then the answer is 0.0099. And this is about 0.99%, or is approximately like 1%. So what happened is that 1% is not more than 5. So more than 5 is unusual, less than 5 is usual. So they said it would be unusual. We say it would be unusual because 1% is less than 5%.